Hello everyone, my name is Vishnu and he is my teammate Karthik Kalyan, and we are doing a product on simulating a gas station model using Arena under the instructor Dr. Ju. So the basically contents of this product are the introduction, objectives, model description, animation, result and conclusion. So first of all, introduction. So what we did basically is we have selected a random gas station in Netherlands, Texas, for studying and studied analysis and simulation. So the first of all, the station has two diesel pumps and six gas pumps. So obviously there are eight pumps in the gas station, and a cashier, only one cashier, and all these things are we have considered as resources. And obviously the entities are obviously the customers or else the cars coming into the gas station. So the customer who is coming to the gas station for filling the gas has two options of paying for the gas. One is by card and other is by cash. So there are apart from the gas pumps, there are two waiting spots for the customers when all the pumps are busy. So the gas station is currently operating for 16 hours a day, which eliminates the customers when the gas station is closed for the other 8 hours of the day. The customers who are paying by cash, they don't have other option to leave, but they leave the gas station without the gas. So the objectives. Let's come to objectives. So first of all, we collect the data on different days. Like we have gone to a gas station and asked the management permission, and we have stayed over there for a couple of hours when the peak hours when the more customers are coming in, and we create a model of the gas station process. So the main objective of the product is to find out the optimal amount of working hours. Like now at present, the gas station is working only for 16 hours. So what we are trying to do is we are making it 24 hours and finding out whether it is profitable or not, and also finding out the available pumps can be optimized to reduce the cost of the maintenance for the gas station. So what are the data we collected? So first of all, the arrival time of the customers, customers coming in, varies the time varies during different time, but in the peak time we have when what we have observed is around exponential of around 6 minutes. So we have taken the maximum time like around 6 minutes, exponential of 6 minutes. The process time of the card is less than 1 minute, obviously. So we have taken the maximum one, so exponential of 1 minute. The process time of filling gas is like around 4 to 5 to 6 minutes. So that we have taken a triangular 4, 4, 5, 6. The approximate customers paying by cash is 40%, and the approximate customers paying by card is obviously 60%. This is approximate because we haven't studied the gas station for complete one day because we are not allowed to do that. So we have studied only for a couple of hours. So what we have observed is 40, 40, and 60. That's why we have taken this approximate. So my friend will continue with the flow chart.
Like you can see, this is the flow chart of the basic gas station model, and the vehicle arrives over here, and we just put a over here decision over here, and it shows whether the pump is available or not. If yes, they just go to the fueling process, or else they go down to the waiting spot and wait until the gas is, I mean, the pump is cleared, so that they can go ahead and refill it. If not, if they choose to not wait, they can just directly leave the station. And over here, there's another decision by the customer based on his or her car. They use whether the gasoline or the diesel. If it's for the gasoline and the diesel, fueling is almost the same process. Like the card has a fast forward process. Like you just pay the pump, fuel it, and just leave the gas station. While the customers who choose to pay it by cash select, I mean, go and check if the store is open or not. I mean, that is for 16 hours. If it's not open, they just leave the store. They just leave the gas station. If it's yes, they just go and pay the cash or grab some groceries on the way, and get out to the pump and fuel fuel their cars. Likewise, for the diesel, it's the same, pretty much the same process. So that causes a trouble if some customers uh, come around the closing time, after the closing time. So the locals who choose to pay it by cash feel it uncomfortable, and they just leave, which is a loss to the store since it's not operating on a 24-hour basis. This is the model which we have designed in Arena, which you have modeled in Arena. And this is the arrival, the vehicle arrival, and this is the assign module which we have assigned the picture and stuff. And we have basically used it using the route and station method since there's no delay at the end of each process. So um, and we have a design model over here which this is basically the model of flowchart which I've explained it earlier, which is modeled on the base of that. This is just a design module over here, like for the decision whether the gas is gas or diesel, or whether the pump is available or not, or whether the store is open or not. Likewise, and we have collected the the data using this model. And let me show you the arena model of that. This is the model which we have modeled in, like I said before. And this is the animation which we have used for this model. And this animation was designed in Microsoft Visio and imported in Arena. So let us run the model and see what the result is. As you can see, the number of replication is 1, and the average number of customers served were 232. Like I said, that was just for one replication, which is not enough. And here is the animation which I've shown you in the model. This was designed in Visio. And the results. We have created two models of the store working hours of 16 hours and the 24 hours of recommended hours, which we find it suitable. And seven different scenarios were run on pan since the one replication was not enough. So we have taken 50 replications and run under seven different scenarios in pan. So that includes both 16 and 24 hours, which is 14 scenarios. And the best was to be found at 24 hours, obviously, since the gas station is open for 24 hours, so that it can serve the customers better and thereby increasing the profit. And this is the pan file, like I said before. These seven scenarios are for the 16 hours, and these are for the 24 hours. Like you see here, it's around 200, 202, and there are a lot of unattended customers due to the shop has been closed. I mean, the gas station has been closed. And this is where you could see like none of the customers are unattended. So whomever, since the gas station open for 24 hours, whomever came in was served. And the maximum was found to be 240, which we find is pretty much good profit for the store. And the conclusion, like the management should be put under consideration since they are the deciding factor whether to run the gas station for 24 hours or not. And we just ran a basic outline from the profit and the net income which we have gathered from the store management. We and comparing it with the 24 hours is and diesel and five gasoline pumps like in the pan file. You see here the 24 is like one diesel pump and five gas pumps. So we find that is the optimal solution because one and seven gas pumps is pretty much the same, but then installing a two gas station, it has a higher capital cost for the management. So around 240 customers or so, like I said before, and comparison to the 16 hours, which are around 200 customers served, and 30, 36 or 37 were left unserved. So that's pretty much it for our project. Thank you.
Thank you.